Okay. Yeah. Okay, today we're going to talk about inner classes. So what's an inner class, you ask? I hear all of you just dying to know. An inner class is when we define a class inside of another class. So this is the one exception to the rule of one class per file. Now you might be wondering why do this? The example that I'm going to work through might explain that. But the biggest use case is going to be when we start doing graphical user interfaces, which will be after we cover inner classes, because that's what is going to make our graphical user interfaces do things. And we also need to talk a little bit about threads, and we're going to do that tomorrow. So there are a couple of all the modifiers that we have in terms of whether it being instance or static can apply to an inner class, and all of the access modifiers can apply as well. But the best practice is to make it private. So the idea is that just like encapsulation is the idea that your data, your instance variables, should be kept hidden from the outside world and only either displayed or modified according to how that class decides it can. In a similar way, with an inner class, we're defining an entire class, but within the scope of a single class, so that the instance of it is likewise encapsulated. And that's why the best practice is to make that inner class private. We'll see what that's about. We can make it static, and there are occasional use cases for making it static. Most of those are demonstration examples. So for example, if doing kind of a quick little demonstration, which I won't be doing here, and all you have is like a main method which is going to just illustrate it. The thing is, because main is static and static things can only see other static things, you have to make if you have an inner class, you have to make it static in that case. But again, private. In 99% of the cases, avoid the static, even though it's possible. And you want to only instantiate it in the outer class, in the enclosing class. So the terms are going to be outer class, that's the enclosing class, and then the inner class is the one inside. And the reason for that is because once you start working with these, there are now kind of two objects running around. Now, everything that we've talked about scope applies here as well. Remember that the rule of scope is kind of within curly braces. So the inner class is within the scope of the outer class, and therefore all of the inner class methods have access to the outer class variables and methods, and actually vice versa. Now the thing is that because the inner class is defined within the outer class, what does this refer to? If I'm in a method of the inner class, what is this? And it's not, well, if you think about it, it's sort of obvious, but it's not immediately obvious, and it's not a law of nature. But the way that it was implemented, which makes sense, is that when you're inside a method of the inner class, this refers to that instance of the inner class. So what comes up is that sometimes you will need to refer to this of the outer class. And how do you do that? You do that by the name of the outer class dot this. So there are two thises running around. And that's another reason why this is kind of not the best name for it, but that's what they chose and they're stuck with it. So within the inner class, Now, when I'm in the outer class, this refers to the outer class. When I'm in the inner class, this refers to the inner class, and outer class name.this refers to the instance of the outer class that you're in. So just as the things to avoid, because of encapsulation, you want to only instantiate the inner class in the outer class, not outside. The other thing to avoid, and this particularly comes up when we start talking about graphical user interfaces, there's something called anonymous inner classes. Those are things where you actually kind of create a class sort of on the fly and you don't even name it. For some reason, when it comes to working with the various widgets of Java, particularly in Swing, a lot of the tutorials and even some of the books will use these anonymous inner classes, and it's a terrible design. So it's something to be avoided. And if you don't know what that is, then good on you. Okay, so to illustrate this, I wanted to do an example which is going to touch on a number of things that we've been talking about. For one thing, it's going to be a class which is a bit more extensive than things we've been working with, so I'm going to work through that. It also is going to illustrate the use of inner classes in a way which mimics in a very somewhat simplistic way the way that Java collections work, specifically with respect to iterators. We've seen in collections that one way to navigate through a collection is to get an iterator and use that iterator to step through. And that's a really effective design because what that iterator is doing under the hood is dependent on what kind of collection you have and what its rules are. So for example, in a hash set, it's just going to kind of go through based upon this inner hashing that it does. If it's a linked hash set, it's going to do it in the order that they were added. If it's a sorted collection, then it's going to go through in the sorted order. So, and if it's like in a list type of thing, it'll go through in the list. But what's nice about that is that you kind of abstracting the idea that we're stepping through this collection, and how we're stepping through it is something which is done using this iterator. And if you remember, the iterator was in fact an interface. And what was powerful about that, it's one of the most effective uses of an interface is because you don't need to know what kind of thing that iterator is actually doing or how it's doing it, because each collection is going to have it done in a slightly different way. But you don't need to know or care about that. Again, the principle of ignorance and apathy. So, that is, you don't know and you don't care. So, one of the frustrating things about working with Java collections, though, is the fact that everything has to be an object wrapper. That is, Java does not have any built-in collection that's based strictly on primitives. Now, in working with them, autoboxing kind of helps a little bit with some of that. So, if I take an integer object off and try to add it to something or assign it to an int variable, for example, then the autoboxing does it all under the hood. If I want to add an int to a collection that contains integer objects, then I can simply do that, and autoboxing will wrap and unwrap it for me. But there are some things that are actually quite clumsy. So for example, if you remember, every collection has a toArray method where if I say, okay, I want to take this, what's in this collection, and turn it into an array. There are situations where you want to do that for a variety of reasons. The problem is, so let's say I have a collection of integer objects. The toArray method, I can with one call, I can turn it into an array of integer objects, but that array of integer objects is not an array of int objects. And so if I want an array of int objects, then I got to do a lot of extra work. So what that means is that if that's a use case that I need, and I want to have a collection that is going to be kind of like an array list, so it's expanding, but I want to work specifically with int objects and not worry about the wrapper stuff. Again, Java doesn't have anything for me. So let's make one. Okay, so this is going to illustrate is we're going to have an int iterator interface, which I'm going to define. Unfortunately, because of generics, it would be wonderful if I could use the iterator interface from collections. But I can't because I'm dealing with primitives, and that, because of generics, will only deal with integer objects. Okay, so I need to define my own interface, and I'm going to call it an int iterator interface. And my class, I'm going to call an int ArrayList class. And then my inner class, and this is this is where the inner class comes in. I'm going to have an inner class, which is going to be an inner class of the int ArrayList, and that's what's going to allow me to use an iterator-like thing to step through that. So let's see